Trigonometric ratios, question 18. Draw the given triangle, solve each triangle and find the sides correct to one decimal place and angles to the nearest degree. Triangle PQR with angle Q equals to 90 degrees, PQ equals to 5 and QR equals to 4. So I'll just make a rough sketch. Let's say this is our triangle PQR, right? So here angle Q is 90 degrees, so angle Q is here, and PQ is 5. Let me say this is P and this is R, right? In that case, we are given that angle Q is 90 degrees, PQ is 5, and QR is 4. Now when we say solve each triangle, well, in this series we have a couple of triangles. So this is one of those videos. Sides correct to one decimal place and angles to the nearest degree. So from given sides, so we are given in a right triangle, legs of the triangle, right? Opposite and adjacent, for example. We can always find angle using tan ratio, right? So we can say tan R is equals to 5 over 4, right? And that gives us angle R is equals to tan inverse of 5 over 4. So we can use the calculator and figure it out. So we have second function tan inverse 5 divided by 4 bracket close. We get 51.34. So 51.34, we need to round it to angles to nearest degree. So we can write this as 51 degrees, right? So that is how we can round and write down this answer. So we can find angle P also. So now to find P, you can take away, this total sum is 90 degrees, right? So you can always take away 51 from 90 degrees and solve for P. That is another way of finding P, right? Or you can do tan inverse of 4 over 5 and get the answer. So it's all up to you. So to find P, what you can do is you can do tan inverse of 4 over 5, right? Because from P, if you see tan is what? 4 is the opposite side and 5 is the adjacent, right? Over 5 will give you angle P, right? Or angle P is also equals to, this total is 180, right? So you can get 180 degrees minus, well, this you can find your answer. 180 degrees minus 90 for this, right? And minus 51 degrees for angle R. So this is another way of finding angle P given these two sides. Okay. Now to find PR using trigonometric ratios, what we can do is we can use sine or cosine to find angle PR, the side PR, correct? Now to really get it accurate, we should use at least 4 decimal places for our angle to get an accurate answer, well? So let me just redo this and say, so I'll write down my answer, what I actually got for angle R to 4 decimal places. So what I actually got for angle R here was equals to 51.3402, rounded to 4 decimal places. That was my R when I did tan inverse of 5 over 4. So we'll use this angle R to find hypotenuse, and now we can find it using sine ratio or cosine ratio. So we can say sine R is equals to, from R if you see opposite side is 5 over PR, right? So PR is equals to 5 divided by sine of 51.3402. So 5 divided by this. So we will find 5 divided by sine of 51.3402. And we get 6.40. So we'll round this to 1 decimal place and we write 6.4. So we get PR as 6.4. And angle R rounded to 1 to nearest degree is 51 degrees, correct? Alternate way to find PR was, of course, you could use Pythagorean theorem, right? Which is 5 square plus 4 square square root and get your answer. So this is how you can solve a given triangle using trigonometry, or you can use Pythagorean theorem also, right? Since we are doing trigonometric ratios, I'll encourage you to solve the problem using trigonometric ratios, right? Now for you test out the result by using, instead of sine, cosine r, right? You can find what cosine r is, right? Cosine r will be 4 over PR. And you can use this ratio to find what PR is, right? You should get the same value, correct? So that's the whole idea. So it's kind of a practice for you. Try to solve problem in different ways, okay? Thank you and all the best.